So in this presentation, I'm going to show you my individual proposal for the Coupa challenge, a complementary proposal. We already used Coupa to design a more profitable DC with Syntec. Now the goal is to extend the solution using methods we've seen in class, like facility, location, transportation models, and heuristics, also systems like reverse logistics and other topics. So let's get into it. A quick reminder that with Coupa, we ran greenfield analysis of the distribution network. We evaluated different combinations of DCs, decided which ones to close, which ones to open, and we also tested changes in ports of entry to reduce both logistics costs and increase the profit compared to the baseline. Now, the result is a more profitable network, but it's mainly focused on one representative year, which is the baseline. It's focused on forward flows only and a strategic location decision, but it doesn't go deep into the last mile routing or reverse logistics. That's where the proposal comes in. A quick overview of our results, where we discovered that three DCs had to be closed. We proposed two new DCs for opening. And for the port, we found that Ensenada had to be replaced with Lázaro Cárdenas. Both solutions had a profit. Now, the objective is to build on top of the network, not to replace it. So I used tools we saw in the course to refine the decisions with the DCs to keep and how to allocate flows using facility location plus transportation models, improve last mile, as I mentioned, performance with simple routing heuristics, and add a digital reverse logistics layer while using concepts of LIS, SCIS, and closed loop supply chains. In short, I want a supply chain that is cheaper, but also more responsive and more sustainable, and aligned with the idea of an adaptive value chain. So the first methodology is a single period facility location transportation model that combines the two topics from the course, which is the transportation problem and the discrete facility location with fixed cost. So I decide which DCs are open or closed and how much product flows from ports or plants to DCs and then to stores will be. So the objective is to minimize the total logistics cost, which will be fixed DC costs, handling, and inbound and outbound transportation costs. I add constraints so that every store's demand is satisfied, DC's capacities are not exceeded, and the flows only go through the DCs that will be open. So this model will allows that through mathematical formulas to validate the network that Coupa suggested and test alternative combinations of DCs and ports using exactly the type of models that we saw in class. Now, method two focuses on the last mile. Once I know which DC serves which stores, I define vehicle routing problem for each DC, similar to the routing or the TSP problems from other courses. So we basically, the truck starts at a DC, it visits a group of stores, it respects the capacity, and then returns. So to build routes, I use simple heuristics. We saw the sweep method to group stores and the nearest neighbor to construct feasible routes. Now, if needed, they can be improved with a simple local improvement like a to opt or other methods. But this reduces kilometers driven, travel time, and even the number of trucks, improving services, the service level, and also reducing transport emissions, which is important for the sustainability aspect of this implementation. Now, method three is more about information and sustainability. So using the LIS, which is the Logistics Information System, and the SCIS, which is the Supply Chain Information System, and supply chain concepts from the module, I propose an information architecture with, the mentioned LIS, SCIS that integrates data from ports, plants, DCs, and stores, a WMS in DCs to control the inventory and picking, and a TMS to support route planning and tracking. On top of that, I integrate reverse logistics, where flows from stores go back to DCs and then to the refurbished, recycle, or final disposal. So we have a closed loop. So this allows us to measure returns, recovery rates, and cycle times, and to reduce waste. With this, the chain becomes a more visible and more data driven, and we move from a linear to a more closed loop, as I said, supply chain. Now, to evaluate the proposal, I would compare the original Coupa network with the network from the facility location plus transportation model and the new routing design. On the cost side, what I would measure the total yearly logistics cost, the cost per kilogram delivered to stores, and the cost per store served. On the service side, I would track percentage of demand delivered within the target lead time, average distance, and time from DC to store, and the number of stockouts or emergency shipments. So the location plus transportation model gives us the strategic flow and cost and the routing heuristics that give me the operational kilometers and times so I can see the combined impact of the cost and service. Now, I also include sustainability perspective. For environmental impact, I estimate that CO2 emissions from transport. I do this using kilometers driven and the emission factor, a simplified CO2 estimate for the DC operations, and, well, the reduction in kilometers versus baseline routes. For reverse logistics, I define KPIs like percentage of returns that are reused, refurbished, or recycled, a return cycle time from store to final disposition, annual reduction in waste sent to landfill. These indicators are, well, the measured in a pilot region and compared with the before and after. In this way, the proposal is evaluated not only by cost, but by the service and their environmental performance, consistent with a more adaptive value chain. So after this, we have compared the original greenfield solution in Coupa, and my complementary proposal adds several benefits, which I think the original work already achieved lower cost and better DC locations and port choices. But my contribution is to give a transparent mathematical model for the DC and flow decisions, explicitly optimize the last mile routing instead of assuming simple allocations, and add a digital layer with the LIS, WMS, and the TMS for better visibility and control, and design basic reverse logistics to move towards a closed loop chain. Overall, well, this turns the solution from a just cheaper into a network that is cheaper, more agile, and more sustainable, which is the spirit of the adaptive value chain. So the proposal plan, this is how I would integrate my proposal into the implementation. Well, phase one is the data model setup, which is cleaning demand, cost, and capacity data and building the facility location plus transportation model with the baseline of 1 year. Now, the phase two is a network and routing design. Well, this would be testing different DCs and port combinations and generating routes per DC with the sweep and the nearest neighbor methodologies, comparing cost and service. And phase three would be a digital and reverse logistics pilot, implementing the basic LIS, WMS, TMS functions in one DC, defining the reverse logistical process for that region and measuring the KPIs for the cost, services, and sustainability. And phase four is the scaling and continuous improvement. This would be deploying the best configuration to all DCs and using the KPIs in the dashboards for periodic review and adjustments as the conditions would be changing. Well, with this, the company has both a solid baseline network from Coupa and a structured path to keep improving its value chain over time. And that would be all. These would be the references, which is mostly material from class and other classes. So thank you very much.